Well, it turns out we have a little bit more to do on 7.2. After looking at the SOL some more, they do want you to do a couple more things here. So the extra stuff we need to talk about is domain, range, and intervals of increasing and decreasing. I haven't written that down because of the format I'm going to use, but you'll see in a moment. So looking at our graph, this is just off the calculator screen. This is what we just did. We want to find domain range, same thing you've been doing before. We talked about a lot of ways to do that. Domain is your x values. Every x value this graph would cover. It could be if you were standing under it looking up, think the part you didn't get rained on. We came up with so many silly little things in class, but basically the question you have to answer is there an x value on this graph somewhere that won't show up, or is everything included? So if you follow this thing, it gets really steep on the ends, but it keeps going to the right forever. Slowly, it goes up faster than it goes right, but it keeps going to the right. And it goes down forever, but it's also heading left forever. So as far as domain goes, we're going to cover every real number again. So this will be another all real numbers. I'm just going to abbreviate all with the real number symbol. And range is y values. How high does it go? How low does it go? This one will probably be easier to spot because it goes up forever, it goes down forever. Also, all real numbers. Okay. Most of these will be all real, especially if they go two different directions on the ends. If you saw one that the ends went the same way, they both pointed down or both pointed up, then you might have a limited range, and we'll talk more about those. All right, part 8, intervals of increasing and decreasing. Basically, I want to know at what points is this graph going up, going back down, and going back up. So any relative maximums or minimums will be your boundaries there. We've already found those. So on a number line, our relative maximum happened at, well, I just did the y value, so I guess I'll need to talk about the x value for it. But hopefully you can see from infinity on, negative infinity on to this point, we're going up. From this point to this minimum, we're going down. So that'd be a decrease. And from this point back up, we're going up. So it's an increase. Okay. So let me translate that into a number line. Okay. Put the graph back up here on the calculator. Let's find the x value for that relative maximum again. So second trace, maximum. All right, so if you're having trouble with this part, more practice, watch me do left bound, right bound. Okay, so again, all I care about is the x value, negative 0.77. Okay, so about here, negative 0.77. All right, so anywhere from infinity or negative infinity up to that point right there, we're going up. So I'm going to draw a little arrow pointing up. It's going uphill. Okay. Now the next interval, it's going to be decreasing, going downhill. So let's find the minimum this time. And again, I need to know the x value. I know the y, but I didn't write down the x value. So looks like about 2.12 for an x value. Okay, so back down here on the graph, 0, 1, 2.12. Okay. So anything in that range, we're going downhill. So decreasing. And anything from that point on back to increasing. Okay. All right, so the way you want to answer this, you want to say that it's increasing, and you got to give some terms of x, domain basically. Anywhere x is less than negative 0.77, and anywhere that x is greater than 2.12. Okay, so for anything less than this negative 0.77, anything more than this 2.12, we're going up. Okay, decreasing is what's in between. Okay, so if our y values are anywhere in that range, we're going downhill. So let's put negative 0.77 as a boundary. Okay. Actually, anything that's bigger than the 0.77 but smaller than 2.12. Whoops. 2.12, not 2.1. So that's 2.12. Sorry about the mess. Okay. So increasing on these two intervals and decreasing on this other part. Okay, 2.12. All right, so that's the extra.